Good day, everyone. I am Irene A. Bakili, and I am tasked to lecture about algorithms involving sets and sequences. I'm going to tackle the sets, the sequences, the algorithms, the sorting, and the pattern matching. But before we go to the algorithms, let us first understand the sets and the sequences.
Set is an object which share the same property. Let's take a pencil as an example of an object. Grouping several pieces of these pencils will form a set. If we take another group of pencils, we will have another set. Looking at these two sets, we will see that they have the same number of objects, although the positions of the colors of each of these pencils are not the same. Sets are considered equal if they have the same values. The position of the objects within the set does not matter. Hence, these two sets are equal. Mathematically, sets are denoted with braces. All of the objects are enclosed within the braces, and these are called elements. Let's take the mathematical interpretation of the above sets. We have a set with elements py, po, pr, pp. Or we have the elements of pencil yellow, pencil orange, pencil red, and pencil purple. And we have another set which has an element of pencil orange, pencil yellow, pencil purple, and pencil red. These two sets are equal. If we take, for example, another two sets with an integer as an element, the 1, 2, and 4 is equal to the other set which has an element of 4, 2, and 1 because these values within the set are equal. Therefore, sets are collections of objects. Maybe it may have finite or infinite values. Sequence. Sequence is an object that has common property. Hence, sequence is also a set. What differs them is that sequence is a group of objects that has an order. Taking the same object as our example, these two sets are not equal if we consider its sequence, because the position of the colors of the pencils within this set are not the same as the position of the colors on the other set. Mathematically, these sets with elements 1, 2, 4 and the other set with elements 4, 2, 1 are not equal if we consider its sequences. On the other hand, these sets are equal because the positions of the color of each of these pencils are in the same order, as well as these sets of integers. The values and the order of the elements of this set are equal to the elements on the other set. Therefore, the sequence of these two sets are equal. We can say that a sequence is a collection of ordered objects. What is algorithm? Algorithm is a precise sequence of instructions or set of rules for performing a task. Algorithms are written for human rather than for a computer to understand. In this way, algorithm differs from programs. In computer science point of view, algorithms are written step-by-step instructions along with its conditions to come up with a program that would yield a desired output. Designing an algorithm involves making steps and rules. Let's have a cake as an example. The problem is, how do we bake a cake? We have recipes for cake. These recipes contain steps. These are step-by-step sequence of instructions on how to make a cake. In computer science, designing an algorithm is thinking logically. then decomposing the problems into bits and pieces. This is called computational thinking or induction. Computer scientists or programmers look for the most effective and efficient algorithm for a problem to have a correct answer. The time and resources for achieving the desired output must be considered. It is preferable to have the quickest running time and to use the small space of the computer memory. Practically, from doing simple tasks such as on how to put the lace of our shoes according to our desired designs, we have different steps for different styles of our shoes, to much more complicated and difficult tasks such as finding the quickest and shortest path to reach destination of an auto-navigated cars and finding the quickest and safest route of an airplane. And then we have the most popular social network site, the Facebook. Almost everyone has a Facebook account. In a shortest time, almost everybody you know or knew become your friend in Facebook, because Facebook has a feature which links you with other friends of your friends. Facebook also uses algorithms for all these features. Every solution to a problem contains algorithm. To come up with a precise and correct outcome, that's why algorithms are important. It is also a key part of a computer science. To do those things, we have common algorithms used involving sets and sequences. These are the sorting and the pattern matching. Sorting. What is sorting? Sorting is an operation that segregates items into groups according to specified criterion. For example, if we have a set A and we have elements 3162134590 and we would like them to appear in an order or sequence from the least to the greatest, we will group these elements and do the sorting algorithm so that we can come up with an order of least to the greatest numbers within the set A. Sorting is also ordering or arranging items in a sequence ordered by some criterion, categorizing grouping items with similar properties, or ordered based on a particular way. Generally, collections of data are presented in a sorted manner. For example, files in a directory are often listed in sorted order, so that if you would like to call a certain person, we will just search the directory. Alphabetically, just imagine if the names listed in the directory are in random order. How much time would it take us to find the phone number of a person? In computer science, we deal with data. It is like a food for programs. Inside the computer memory and servers, there are large amounts of data. If these data are unsorted, it will be too difficult for a programmer to retrieve the needed data. So we have the primary sorting algorithms: the bubble sort, the quick sort, the merge sort, the insertion sort, and the selection sort. All these primary sorting algorithms have become the basis of advanced algorithms at present. The bubble sort makes multiple passes through a list. It compares adjacent items and exchanges those that are out of order. Each pass through the list places the next largest value in its proper place. In essence, each item bubbles up to the location where it belongs. For example, we have this set with elements in a random order. We want these elements sorted to an order of numbers from least to greatest. using bubble sorting algorithm. Elements within the set are compared from left to right. In our case, the first element from the left must be the list of all the numbers within the set. Therefore, we compare if the first element from the left is less than the second element. In here, 4 is greater than 1, so we shift 1 to the left. After shifting the elements, we compare the second element with the third element. 4 is less than 5, therefore there will be no shifting of numbers. Then we go on comparing the third element with the fourth element. 5 is greater than 2. In this case, we shift the lesser number, which is 2, to the left of the third element. Then we go to the fourth element and compares it with the fifth element. 5 is greater than 3. 3 will be shifted to the left. All the elements have been compared. In bubble sort, this is called the first pass. Since the numbers are not yet sorted according to the order that we would like to have, we go back to compare all elements from the left side. 1 is less than 4, so there will be no shifting of numbers. We go on to the next element. 4 versus 2. 4 is greater than 2, so we shift 2 to the left. And then we compare the third element with the fourth element. 4 is greater than 3, therefore 3 will be shifted to the left and 4 to the right. Afterwards, we go on to the last two elements, the fourth and the fifth element. 4 is less than 5, therefore there will be no shifting of numbers. After all the elements have been compared, this will be considered as the second pass. Then we compare again all the elements from left to right. Since all elements are in order now according to our preferences, the comparing stops, and we have the sorted set now from least to the greatest sequence of numbers. So, bubble sort analysis, the running time. Worst case is 0n to the 2. Best case is 0n. The variant bidirectional bubble sort. The original bubble sort only works to one direction, and bidirectional bubble sort works back and forth. Quick sort. Quick sort is a divide and conquer method. The crux of the problem is how to partition the array such that the following conditions are true. There is some element in an array A where array A is in its final position. For all elements of L less than I, array A is less than to array A with elements I. For all I less than R, array A with elements I is less than array A with elements R. In quicksort, we always pick first element as pivot, or we always pick last element as pivot, or pick a random element as pivot. Pick median as pivot as illustrated here in our example later on. So taking the same list of elements, we have 4, 1, 5, 2, and 3. In the quick sort, we choose our pivot. In this case, we choose the middle as our pivot. And then we compare all those numbers. small numbers to the left of the pivot, and large numbers to the right of the pivot. Repeat until all elements are in sorted order. So we choose again our pivot, which is in the middle. Then we compare again all the numbers and shift all the small numbers to the left of the pivot and large numbers to the right of the pivot. Therefore, we achieve the order of our preferences, which is in a sequence of least to the greatest number. Quicksort analysis. Quicksort is more widely used than any other sort. Quicksort is well studied, not difficult to implement, works well on a variety of data, and consumes fewer resources than other sorts in nearly all situations. Quicksort is O and log n time and O log n additional space due to recursion. We go on to the merge sort. Merge sort is like quicksort. It is a divide and a conquer algorithm. It divides input array into two halves, calls itself for the two halves, then merges the two sorted halves. For example, taking the same elements as previously illustrated, we have the 4, 1, 5, 2, and 3. In merge sort, we divide these arrays into two halves. Then these halves will be independently sorted repeatedly. So all the lesser numbers will be shifted to the left and the greater numbers will be shifted to the left. So 4 will be shifted to the right and 1 will be shifted to the left. In this group, we will do the same sorting. All the lesser number to the left side and all the greater number to the right side. So 2 will be shifted to the left and 3 will be shifted to the left, while 5 will be shifted to the right. After the sorting of each of these halves, we merge the list. So merging these elements, we have to come up with an auxiliary space for the sorted elements. First, we compare the first element within the first half and the second element within the second half. So first element 1 and 2, comparing these two, we will have 1 as the lesser value. Therefore, we put 1 into the sorted auxiliary space. Afterwards, we move to the next element within the first half, 4. We compare it again with the first element of the second half. So 4 is greater than 2, therefore 2, we go on to the sorted space. Since 4 is still not sorted, we compared 4 with the next element within the second half, which is 3. 3 is less than 4, therefore it will be going to the sorted portion of our auxiliary space. Then still 4 is not sorted, so we compare 4 with the rest of the elements in the second half. 4 is less than 5, therefore 4 now is going to the auxiliary space of our array. And then the remaining element is 5. Therefore we have now sorted our list. Merge sort analysis. Running time, worst case 0n log n, best case 0n log n. In selection sort, this sorting algorithm is an in-place comparison-based algorithm. The list is divided into two parts, the sorted part at the left end and the sorted unsorted part at the right end. Initially, the sorted part is empty and the unsorted part is in the entire list. In selection sorting, we select the best item from the unsorted group, then put the best item at the end of the sorted group. In our case, our best item is the largest number. Repeat the process until the unsorted group becomes empty. So we are taking another set of elements. We have 4, 1, 5, 2, and 3. This is the unsorted list. We scan sequentially from left to right, from the first element to the last element within the list. After sequential scanning, we found out that 5 is the best item within the list. Therefore, 5 will be swapped to the last element at the right side. And this is the sorted element. Again, we scan sequentially from left to right. 4 is now our biggest or the best item within the list. So we swap it to the second place of the sorted element, which is 2. We do sequential scanning after we have sorted the elements. Now we have 2 and 1. We have the 2 as our best item, therefore we swap it with the unsorted element. Now we have the sorted element, so 1, 2, 3, and 4, 5. This is the selection sorting. Selection sort analysis. Running time, worst case 0n to the 2, best case 0n to the 2. It is actually inefficient on a large list because it takes time to recursively on scanning the list. So we have the insertion sort. We have two groups of items, sorted group and unsorted group. Initially, all items in the unsorted group and the sorted group is empty. We have to keep items in the sorted group sorted. Pick any item from the list, then insert the item at the right position in the sorted group. Taking the same element, we have 4, 1, 5, 2, and 3. Set a marker between the sorted and unsorted elements. Therefore, we choose our marker here between 1 and 5. Select the first unsorted elements. We choose 4 as our unsorted element. Then we compare the elements, shift the lesser value to the left side and the greater value to the right side. Move the marker to the next unsorted element, which is between 5 and 2. Then again, compare the elements, shift the lesser value to the left side and the greater value to the right side. Move the marker. Then compare the elements, shifting the lesser value to the left side and larger value to the right side. Now we come up with this sorted number. Insertion sort analysis, running time analysis, worst case 0n to the 2, best case 0n. Now we go on to the pattern matching, string matching algorithm. In string matching, we look for the occurrences of the pattern in a search or in a series of strings. For example, we have this pattern, the my string. We're going to look or compare the occurrences of this string in this series of strings. String matching algorithm is developed by Nath, Morris, and Pratt 1977, and it is known as the KMP algorithm. It is an important class of string algorithms that try to find a place where one or several strings are found. These are called patterns within a larger string or text, which is called search string. The search behaves like a recognition process by automaton, and a character of the text is compared to a character of the pattern. The string matching algorithm. For example, we have pattern MIN, and we want to search the occurrence of this pattern in the search strings. These are the search string. In string matching algorithm, we're going to compare the first character in the pattern to the first character within the search string. M is not equal to E, so we go to the next character within the search string comparing M with this character. M is not equal to either, for we go on to the next character within the search string. In this case, M is now equal to M. Therefore, we go on to the next character within the pattern, I. Then compare it with the next character in the search string, which is I. This is equal, therefore we go on to the next character within our pattern and compare it with the next character within the search string. N is not equal. This is now a mismatch. Therefore, in string matching algorithm, we go back to M and compare it all over again with the next character. We have a pointer. Therefore, this pointer is now moved here. Every time the occurrence of mismatch comes out, we move the pointer in the search string. So we're going to compare M with this character. M is not equal to either, for we go to the next character within the search string. N is equal to M, therefore we're going to compare I within our pattern with the next character within the search string. I is equal to I, therefore go on to N and the next character within the search string, which is E. In this case, we now have a mismatch again. In string matching algorithm, as long as there is a mismatch, we're going to go back and compare the first character within our pattern. But the pointer in the search string will be incremented. So we will start here. M is equal to M. Therefore, we go on to the next character within a pattern and compare the next character within the search string. I is equal with I, therefore we move on. N is not equal with E, we now have another mismatch. So the pointer will be incremented and move on to the next character within the search string. But we go back comparing the first character within our pattern. So M and I is not equal. We move to the next character comparing M. M is not equal to E. We go on to the next character within the search string comparing our first character within our pattern, which is M. M is now equal to M, therefore we're going to the next character within our pattern, which is I. I compared to this next character I, is also equal. Therefore, we go on to the next character within our pattern, which is n, and compare it with the next character within the search string, which is n. Now n is not equal to n. Therefore, we move on to the next character within our pattern and compare it with the next character within the search string. Since E is equal to E, now we have an occurrence of our pattern within the search string. Now we have matched the string and we are finished with string matching. This is how string matching algorithm is done. String matching analysis. Running time, best case 0n.
That's all for today, guys. Keep on watching our channel for more videos. Don't forget to subscribe and like our channel. Have a nice day.